Yes, hello. So now we're going to be looking at a repeated factor of polynomials. So what is a repeated factor? A repeated factor is like having the same factor twice, like let's say x minus a squared. Like it means you have x minus a and x minus a being factors. And what is a factor? Factor is a number which, if it divides a specific expression, it gives no remainder. That's what the word factor means. So now here we have a polynomial f of x. We are saying this polynomial is being expressed as a product of this factor, like this is squared, so this is a repeated factor, and any other function gx, but the function we have in question is f of x. Now we want to get a condition for all polynomials that have repeated factors. Now don't confuse this with a repeated factor of quadratic equations. It's a different thing. A repeated factor of quadratic equations and a repeated factor of polynomials. Now in the repeated factor of quadratic equations, or repeated roots, actually we even call it repeated roots, we said for that case it's going to be b squared minus 4ac is equals to 0. That's the condition for repeated roots of quadratic equation. But repeated factor of polynomials, we are not going to come up with our condition here. So we have to differentiate this. Like to come up with our condition, we're going to differentiate this function to get its derivative. The derivative is the value you get after differentiating. Now, to differentiate this, we are going to use the, I think the product rule. Don't worry, for those who are facing challenges, you'll watch our video on differentiation when it's ready. So now we have this. Now you know to differentiate this, it would be u dv dx plus v du dx. So now we are going to say what is our derivative. So we say what is u? U is x minus a squared. What is dv dx? We differentiate this. This is this plus v. What is v? G of x du dx is going to be 2 into x minus a into 1. So we have f inverse, like not inverse, but like f, the derivative of this function is going to be x minus a squared g of x plus g of x, and then this is 2x minus a. So we are going to factorize out x minus a. So this is f inverse of x is equals to, this is x minus a here into x minus a g of x. This is like the derivative, like g prime. Now here I'll bring the 2 in front with. Okay, so now we have this. So now I want us to note this is the condition. Now the condition is that if the factor, this function f has a repeated factor, x minus a squared, it's a repeated factor, then x minus a is also a factor of the derivative of that function. So this is what we're trying to prove, that when you have this function having a repeated factor of x minus a squared, but now you see that when you get its derivative, you realize that the derivative of that function also has x minus a as one of its factors. So what does that mean? In many of the questions that when we're talking about polynomials having repeated factors, always just as an instinct, we're always going to try and find their derivative. And knowing that when you find their derivative, one of the factors of that derivative is going to be the repeated factor. I don't know if that makes sense, but we are going to look at a few examples and I hope it will make more meaning. Okay, so now now let's look at this example. Given that the polynomial this has a repeated linear factor, find the possible values of k. So now this is our polynomial, which is f of x is equals to x cubed plus 3x squared minus 9x. This is our polynomial. And the question is saying, given that this polynomial has a repeated factor. Now, this plus k. So you can notice that here there's an unknown. So there may not be so much we can do with this in its raw form. But you remember that the condition for any quadratic equation to have a repeated factor is that the repeated factor will also be a factor of the derivative of that function. So here let us find the derivative of this. Like the derivative is what we get after differentiating. So this will be 3x squared plus 6x minus 9. This is a constant, so the rest is 0. So now we want to factorize this thing and find its factors, and we shall know that one of the factors of this thing will be the repeated factor. Okay, so now here we have this. So I want us to factorize it. So it's a factorization. I want us to take out the 3, this plus 2x minus 3. So now we're going to factorize this. So we have what is the sum? B is 2. Then the product SC will be 1 times negative 3. Negative 3, you look for the factors of negative 3. 1 times negative 3, and then you also have negative 1 times 3. You have to get what of this, that when you multiply you get negative 3, but when you add you get 2. I think we all agree that that is negative 1, 3. So when you factorize this thing, eventually you're going to have this is 3 into, okay, let me first work it out on its own, just as it's easier to understand. X squared minus x plus 3x minus 3. So here what do we have? We end up having x plus 3 into x minus 1. So eventually we'll say f, this will be 3 into x plus 3, then x minus 1. So meaning these are the factors of the derivative. You have x plus 3 and x minus 3. But now we say one of these factors is the repeated factor. Another question said find the possible values of k. So now we're going to get this and say x cubed plus 3x squared minus 9x plus k. So we're assuming now both of these are factors, since we don't know which one is the repeated factor. So we're going to substitute in both. Now this, from our previous lesson, you realize that when you divide the factor by this number and it's a factor, the remainder will be 0. So now we can substitute the way we've always been substituting. Here x is negative 3. Substitute negative 3 here, plus 3 into negative 3 squared minus 9. Negative 3 plus k is equals to 0. So here we have k is equals to negative 27. Then now we also put the second one. We have x squared into x squared minus 9x plus k is equals to x minus 1. Remember, we have said these are factors, so that means they give a remainder of 0. So here x is equals to 1. Then now we substitute 1 into this. 1 squared plus 3. 1 squared minus 9 plus k. This is equals to 0. So we get the value of k is, if I remember the question I said find the possible values of k. So we are not sure which is the exact possible value, but these are both, which is like the exact value, but both of these are possible values. Why? Because we don't know which of these two is the repeated factor. Okay, now this question says given that fx is equals to this, show that f inverse of x is divisible by this. So this is similar to the first thing we had done in the previous, as we're introducing this concept. Come and say f of x is equals to x minus this squared g of x. So factorize. So I'm doing it like this because we have done it before, plus 2 into x minus alpha g of x. So you have this, you factorize out x minus alpha, so you get x minus alpha g of this plus 2 g of x. So here I've shown that the derivative is divisible by this, and by just doing this we've showed this, though I didn't go that long, but you should know that this is, we're using the product rule. Alright, so now let's look at another example. So this is not another example, but this is a continuation of another question. So it says a polynomial px is equals to x cubed plus 4ax squared plus bx plus 3 is divisible by x minus 1 squared. Then use the result in A above to find the values of A and B, hence solve the equation. Now, so here we have this polynomial is divisible by x minus 1 squared. So, and the fact that it's squared, that means this is a repeated factor. So meaning we're going to come and say x cubed plus 4ax squared plus bx plus 3 is equals to x minus 1 squared quotient plus the remainder of 0 since it's a factor. Then we say x minus 1 squared is equals to 0. Find the square root on both sides. X minus 1 is 0. So x is equals to 1. We substitute 1 in here. We have 1 cubed plus 4a, 1 squared plus b into 1 plus 3 is equals to 0. So we have 1 plus 4a plus b plus 3 is equals to 0. So what is this? We have a 4a plus b plus 4 is equals to 0. 4a plus b is equals to negative 4. So we're going to call this equation 1. But remember we said what is px is equals to x cubed plus 4a squared plus bx plus 3. Now we want to get the derivative of this, because once we get the derivative, this repeated factor is also a factor of the derivative. So we have this is 3x squared plus 4. Sorry, this is not 4. This comes and this is 8a x plus b. So this is the derivative. But now we said that it's the derivative 3x squared plus 8a x plus b. But we said for any equation to be called to be said to have a repeated factor, for any polynomial, sorry, to be said to have a repeated factor, that repeated factor is also a factor of the derivative. So meaning when we say this is equals to x minus a, it also gives you a remainder of 0. So this is x minus 1 is equals to 0. X is equals to 1. We substitute here 1 squared plus 8a into 1 plus b. This is equals to 0. So this is 3 plus 8a plus b is equals to 0. So what do I have? 8a plus b is equals to negative 3. So now I have these two equations, and I solve these equations simultaneously. Now here you're free to use whichever method of solving simultaneous equations you want, and you get the value of a as a quarter. If you're having issues with solving these equations, you can look for our video on simultaneous equations. So this is a is a quarter, b is negative 5. But the question says find the values of a and b, hence solve the equation. So we have not yet finished. We're supposed to come and say, but our equation is x cubed plus 4ax squared plus bx plus 3. So we substitute, this is x cubed plus 4 into a, which is a quarter, x squared plus b, this is negative 5x plus 3. So we will eventually have, this is x cubed plus x squared minus 5x plus 3. Now the question has asked us to solve this equation. And from this equation, we already know that the polynomial is divisible by x minus 1 squared. So x minus 1 squared, it's a repeated factor. So now we have many ways we can solve this. One way we can solve it is by saying, since the question wants us to solve the equation, we already have two factors. We want to find a third factor. Okay, so how do we do that? We are going to say x minus 1 squared is a factor. So meaning, what is when we square this, we're going to get x squared minus 2x plus 1. So now we are going to divide by long division. Here we have x cubed plus x squared minus 5x plus 3. Here we have x squared minus 2x plus 1. So remember what we said. We come here and say we're going to start with x cubed. X cubed divided by x squared is x. So here we put x. So here we have x cubed. I'm multiplying this by everything here, minus 2x squared minus x. So we have this, subtract. So this goes, then we have 1 x minus minus. So this becomes 3x squared. Then I have minus 5 minus x. So here I think I get negative. I think I get negative 4. Sorry, this was a plus. I think we made a mistake. This was a plus. Such that when we come here, we say this is negative 5 minus x, negative 5x minus x. This becomes negative 6. Sorry for that mistake, negative 6x plus 3. Now the next thing, I'll come here and say this time I have 3x squared divided by x squared. What do I get? 3. So I get here plus 3. Then I take everything here, 3x squared minus 6x and then plus 3. So you see I get no remainder, but I get this. So meaning this expression can be written as a product of these two. This will be equivalent to our expression. So meaning our roots are, so if you call this to 0, this will be x is equals to negative 3. But remember, we already had the repeated root, so you see, so these are the roots of this, or these are the roots of this equation. And since it's a polynomial of a power of highest power 3, it should have 3 roots, as we've seen here. And okay, now let's look at another example. This one says find the roots of the equation, this given that it has a repeated root. So now for this equation, now I think towards the end of this chapter, we're going to see how to solve these polynomials when you've not been given any condition, because you realize this equation can be solved like x squared minus 6x, x cubed minus 6x squared minus 63x minus 108 is equal to 0. This can be solved using we're going to see try and error method, where you find one root then you find the other roots. But this question has given you a condition given that it has a repeated root, so the examiner would want to see using this condition. So that's why you don't just solve say maybe let me try an error method then I find one root. We are going to see how that works at the end. So now here we have find the roots of the equation this. So maybe we can let it be maybe f of x be this 6x cubed minus 6x squared minus 63x minus 108. Now every time someone talks about a polynomial having a repeated root, they would want to see you find its derivative. Why? Because we said that if a polynomial has a repeated root, that repeated root that repeated root will also be, that repeated factor will also be a factor of the derivative. So here I have minus 12x minus 63. So I have this. Now we would want to factorize this, but as I told you, it's always easier to factorize out maybe here the 3. This becomes x squared minus 4x minus 21. So we have this. So maybe let me take this out. I can say consider x squared minus 4x minus 21. So I want to like work with this. So I'm going to say what is the sum. B is negative 4. The product SC is going to be negative 21, which is 1 times negative 21. So you come on your side, I can say the factors of negative 21. You have 1 times negative 21, then you have 3 times negative 7. But I told you always try to interchange, because here we have even this, then you have even negative 3 times 7. So you look for something here. This is a positive. So you look for something here that when you multiply gives you negative 21, but when you add it gives you negative 4. And I think for this case it's going to be negative 7 and 3. So negative 7, 3. Now we're going to say this is x squared minus 7x plus 3x minus 21. So eventually this becomes x plus 3, x minus 7. So eventually we have f inverse of x is equals to 3 into x plus 3. Then this is x minus 7. So the factors are x plus 3 and x minus 3. So, but even if someone had not factorized and maybe they had 3x plus 9 as one of their factors, it would still be correct. It would give you the same answer. It's just that when you factorize, when you like take out the 3, what I mean, when you take out the 3 here, it makes this very easier to solve. But if you don't, you still get the answer just that it will be, it will take somehow long. So here, the factors are x plus 3 and x minus 7. So one of these is our repeated root, but like we can't tell of course from here, as I told you last time, but we know that one of these is our repeated root. So what do we come and say? We now get one by one. We can start with x cubed minus 6x squared minus 63x minus 108. We equate it to this. So if this is a repeated root, it should give us a remainder of 0. Because if it's a repeated root, if it's a repeated factor, so that means it's also a factor of the expression. So we equate this to 0. So we have x is equals to negative 3. Substitute this here. We get minus 6. Negative 3 squared minus this minus 108. This should be equal to 0. So here what do we have? We have 0 is equals to 0. What does that mean? X minus 3, x plus 3 is a factor of this, and x is equals to negative 3 is a root. Then we have x cubed minus 6x squared minus 63x minus 10. Now we are going to bring our second factor, which is x, because we want to see the remainder should be 0 if it's the repeated root. So here we have x is 7, then we substitute in, we have 7 cubed minus 6, this is 7 squared, minus 108, this is equals to 0. And when you subtract this, you get negative 500, but that is not equal to 0. What does that mean? X minus 7 is not a factor. It's not a factor. What does that mean? X is equals to negative 3 is the repeated root. Because as I told you, one of these is the repeated root, but we don't know yet. But how do we know? When we get this and this, and we substitute them into these, the one that gives a remainder, like no remainder, like a remainder of 0, is the repeated factor. And in this case, we'll have x, this is the repeated root, and x plus 3 is the repeated factor. Okay, so now since we have this is the repeated factor, meaning the question wants us to find the root. So we have this is a repeated factor. So we can do the same way we did last time, or we can even do another way. So we can do, so that this is x plus 3 squared is a factor. So we can expand this and say this is x squared plus 6x plus 9. Then we use long division like we did last time and say this is x minus 6x squared minus 63x minus 108. This, then here we put this here. Then now we find value here. Then like we did last time. Oh, now I want to give us another way. So the roots, we have x alpha is equals to negative 3. We have beta is equals to negative 3 since it's a repeated root. Then maybe gamma is what we don't know. But you know that the sum of the roots from the thing of cubic equation, since this is a cubic equation, the sum of the roots is going to be negative b out of a. And here what is this? Is negative 3 plus negative 3 plus gamma is equals to negative b. What is our b? Negative 6. So this is negative 6. A is already 1. This is negative 6 plus this is equals to 6. So 12. So you see, this is the third root. But still, someone who goes this way will still find the third root as 12. Here I just wanted to give us another alternative. So now this question says a quadratic polynomial px, p of x leaves a remainder of negative 6 on division by this, a remainder of. So now the first thing, before we even finish reading the question, when the questioner said a quadratic polynomial, you should know that the standard equation for a quadratic equation is ax squared plus bx plus c. So now we can now start interpreting what we have here. The question is saying that this equation so now we are seeing that this quadratic polynomial leaves a remainder of on division by this. So meaning it's being divided by this, it's leaving a remainder of negative 6. So we can now first work with this x plus 1 is 0, x is equals to negative 1. So we substitute this in plus c. Remember this, we quoted all of this to 0. So this is equals to negative 6. Here we have A minus B plus C is equals to negative 6. I call this equation 1. Then I bring back our expression plus C is equals, and gives a remainder of negative 5 on division by x plus 2. Here I have the remainder is negative 5. So I say this is x plus 2. I equate it to 0. X is equals to negative 2. Then now here what do I have? A negative 2 squared plus B into negative 2 plus C. This is equals to negative 5. So I end up having this is 4A minus 2B plus C is equals to negative 5. So I call this equation 2. Then I bring back ax squared plus bx plus c. Sorry. Then now here they say a no remainder on division by. So x plus 3, the remainder is 0. So I say x plus 3 is 0. X is equals to negative 3. So here I have a into negative 3 squared plus b into negative 3 plus c is equals to 0. So what will I have? I have 9a minus 3b plus c is equals to 0. I call this equation 3. So this is equation 3. So now what do? We solve 1, 2, and 3 simultaneously. So I won't do that because I don't want to make this video very long, but we have videos on simultaneous equations. So you can, if you don't know how to do it, you can watch that and see how it's done. Right now, what will be our values of a from solving? We get our value of a as 2, our value of b as negative 5, our value of c as negative 3. Now when we substitute this into, we get this is 2x squared plus 5x minus 3. This is our quadratic equation. And they even said solve the equation. When you solve it using any method of your choice, this is a half. Now let's look at this briefly. I find the values of p and q which make x plus 4 x squared, x to the power 4 plus 6x cubed plus 13x squared plus px plus q. So now, okay, so we're saying for this question we've talked about a perfect square in one of our chapters on quadratic equations, but now this is for power 4. So when the question says a perfect square for power 4, we're going to say this is plus 13 squared plus px plus q. We say this should be equivalent to this plus c squared. So we have this, then we expand this. We can say this is ax squared plus bx plus c squared. So this is equals to ax squared plus bx plus c into ax squared plus bx plus c. Now expanding this is a really long process, but I'm going to pause, then I expand it, then I play when I've expanded it. Okay, so sorry, this is it. Now we are going to compare coefficients. So I've not put the entire working here because it's going to make the entire place crowded, but if you expand this step by step, you're going to come up with this. So we're going to compare coefficients, comparing coefficients. So I'm going to start with coefficients of x to the power 4. So here, x to the power 4 here, here it's a squared is equals to here it's 1. So here I'll say a is 1. Then now I go to coefficients of x cubed. Here it's going. Okay, so now here we're going to say for x cubed is going to be 2ab is equals to 6, but we have gotten a is 1. So times b, this is 6. So we end up having b is equals to 3. Then we go to x squared. Sorry, here if I missed to put this is b squared. Sorry, this is b squared. So we have this will be b squared plus 2ac is equals to 13. Since after it's 13. So we end up having this is 3 squared plus 2 times 1 times c is equals to 13. So what's the value of c? C is 2. Then now we go to the coefficients of x. where we have p will be equals to 2bc from comparing coefficients. So we have p is going to be equals to 2 times 3 times 2, since what was our value of b was 3. So we end up having p is equals to 12. Then now we go to the constant terms. Constant terms, we're going to have q going to be equals to c squared. So q will be equals to c, remember we found out c as 2, so this is 2 squared, then q is 4. Now, okay, before I substitute this into the original equation, I wanted to talk about something that you realize here. When we say a squared is 1, we don't say the value of a is plus or minus 1. It's because this question is already very lengthy, so usually we just tend to go with the positive. So when you say the square root of 1, you don't say plus or minus 1, we just say it's 1. But usually when you find the square root, you should always have plus or minus. But in this case, usually we just say 1, we go with the positive values. Okay, but now you see we found the value of p, we found the value of q, so we can even substitute it and find that equation. And you realize if you solve this question, you realize it's a perfect square. Okay, now we're looking at the last set of examples in polynomials. So this question says a polynomial expression fx when divided by x minus 1 leaves a remainder 3. So this is our polynomial expression when divided by x minus 1 leaves a remainder of 3. Hope now by now this makes sense to everyone. And when divided by x minus 2 leaves a remainder 1. So the remainder is 1. The question says show that when f of x is divided by this leaves a remainder, right? So we are going to say let the remainder on division by x minus 1, x plus 2, be x plus 1. Because now, okay, for this question, let me first show you this. They've told us that when this function is divided by x minus 1, the remainder is 3. When this same function is divided by x minus 2, the remainder is 1. Now what does the question want? The question wants us to find what is the remainder when this same expression is divided by both of these, like x minus 1 and x minus 2 at the same time. So now we don't know that. How would we find that is what we are now trying to see. We are saying let the remainder on division by this, such that now we are saying on division by this at the same time, q, which is like the quotient as we say. Now the remainder will be ax plus b. What we don't know, and we're going to equate each of these to 0. So now, just like we're dividing through by x minus 1. So we'll say f of 1 will be, this is 0, and this will be a plus b, since this is ax plus b. Now, but we know the remainder of this thing on division by, we said the remainder be ax plus b, so here we've substituted. Now, here we know that the remainder on division by x minus 1 is 3. So we are going to say a plus b is 3. I don't know if this makes sense. Then we are going to again repeat f of x is equals to x minus 1, x plus 2, q plus ax plus b. This time we say x plus 2, we equate this to 0. So we have x is equals to negative 2. So f of negative 2, this is 0. And then here we have a into negative 2 plus b. So we have negative 2a plus b is equals to f of negative 2a. But remember we said, I think I've interchanged, sorry. The question said x minus 2. Me, I interchanged here and I put x plus 2. Sorry, this is x minus 2. I think let me clear that now. Let me clear this now. Let me clear this error now. So here we said we have x minus 2. Here we have x minus 2. Here we have x minus 2. So this is x is equals to 2. So this is even f of positive 2. So we have this is a into 2 plus b. So here we have 2a plus b. So but now what is the remainder on division by x by negative 2? It's 1. So we have 2a plus b is equals to 1. So we have this is this is 1. This is equation 2. So what do we do? We're supposed to solve equation 1 and equation 2 simultaneously. And what do we get? We get A is -2 and we get B is 5. So the remainder, we substitute this into ax plus b. The remainder will be -2x plus 5. So this same concept that we have seen here, when a polynomial is divided by x plus 1, the remainder is 7. So you're going to say let the polynomial be p of x. So when it's divided by x plus 1, the remainder is 7. When the same is divided by x minus 4, the remainder is -8. So we are going to let the remainder on division by both be ax plus b. Since the question asks us to find the remainder when the polynomial is divided by x by both of them. So now we come and say this is going to be equals x plus 1, x minus 4 into the quotient plus ax plus b. So we start with x plus 1 is 0, x is equals to -1. So p of -1 is going to be, this whole thing is 0 into a -1 plus b. So p of -1 is -a plus b. But remember the remainder on division by x plus 1 is 7. So -a plus b is equal to 7. Since this is like the expression for the remainder. I don't know if this makes sense. So now we also come and say, but we repeat px is equals to x plus 1, x minus 4 to the quotient plus ax plus b. By this time we are going to go with x minus 4 is 0. So x is equals to 4. So p of 4 is going to be, this whole thing becomes 0 into this is plus b. So this thing becomes 4a plus b. Then now we are going to say, but the remainder on division by x minus 4 is -8. So we have 4a plus b is equals to -8. Call this equation 1, we call this equation 2. So we just solve these two equations simultaneously. And we will get a is -3, we get b is 4. But our equation is ax plus b. So we have -3x plus 4 is the remainder. Okay, now we're going to look at these briefly. These two examples we have when this function, which is equals to this, is divided by x minus 4 squared, the remainder is that. Given that x plus 1 is a factor, find the values of a, b, and c. So we're going to see this faster. So we have this expression, and we are saying it's divided by, when it's divided by this, the remainder is 2x plus 11. So we first even work with this before we even go any further. We equate this to 0, so we have x squared is equals to 4. Find the square root. So now here we'll say what is the value of x. X is plus or minus 2. So meaning x is 2 or x is equals to -2. So we are going to equate one at a go. So when x is 2, so here we'll come and say this is 2 cubed plus 2. Remember, when you substitute everything into everything, you don't just, this becomes 0. So here we have it equals to 2 into this. So here we have 8 plus 4a plus 2b plus c is equals to 4 plus 11. So eventually you'll have 4a plus 2b plus c is equals to 7. This is equation 1. Then so this, but you also say when x is -2, you also substitute -2 cubed plus a into this plus b into this becomes 0 is equals to into -2 plus 11. So here what do we have? -8 plus 4a minus 2b plus c is equals to this will be equals to 7. So our final equation will be 4a minus 2b plus c is equals to 15. So this is equation 2. Then now the question also told us that this is a factor of that same expression. So we say x cubed plus ax squared plus bx plus c. This is going to be equals to x plus 1. Since this is a factor, the remainder will be 0. So x plus 1, 0. x is equals to -1. So here this would be -1 cubed plus a into -1 squared plus b into -1 plus c. This is equals to 0. So we'll have this is -1 plus a minus b plus c is equals to 0. So we have a minus b plus c is equals to 1. So this is equation 3. So we solve 1, 2, and 3 simultaneously. We'll get a's 4, we'll get b's -2, we'll get c's -5. So I wanted us to go now. Let's finalize with this. Given that x squared minus x minus 1 is a factor of this, find the values of p and q. Now for this question, what makes it tricky is you can't use long division. Why? Because we have an unknown. So what we do for this question, we're going to say, since this is 2x to the power 4 minus 3x cubed plus px squared plus qx minus 3, we're going to say this should be equivalent to, we are like going to use the concept of the perfect square. So this plus 1, and then now we get another this quadratic, this. Now when you expand this, you will have something like x power 4 plus b minus a into this plus c minus b plus a. This is x squared plus b minus c x plus c. Now we can compare the coefficients of this with this. This is one way we can solve this. So comparing coefficients, start with x to the power 4. Here a is 2. Then we go to x cubed. B minus 1 is equals to -3. So we have b minus 2 is equals to -3. B is -1. Then we now have x squared. This is c minus b plus a is equals to p. So we have c. Okay, so now we've compared the coefficients for x squared. We have c plus 3 is p. We call this equation 1. So I want us to compare the coefficient for x, but before x, I think it's better if we first compare the coefficients for the constants, for the constant terms. So we come here and say constant terms. So for the constant terms, c is equals to -3. So if you have c is -3, we can even find the value of p here by saying -3 plus 3 is equals to p. So our value of p is 0. After that, now I can say comparing the coefficient for the x term. I'm going to have b minus c is equals to q. And this will be -1 minus 3 is equals to q. So this is -1 plus 3 is equals to q, meaning q is